Proton, the uncertainty in the velocity for proton will be not much, because proton is heavy. Proton is about 2000 times heavier than electron. So electron in energy units, its mass is 0.511 MeV, while proton's mass in energy units is 938 MeV. So therefore, proton is 2000 times almost heavier than electron. So proton's uncertainty in velocity will be not as high as electrons. So therefore, we will talk about electron. So I will put subscript E, saying that this is the electron's uncertainty in the speed. Why is this uncertainty in the speed important? Well, it turns out that uncertainty in the speed of these electrons is so large that this constitutes the pressure, not the temperature. White dwarf also has some, normally white dwarf is also hot, but it doesn't have its own heat source. So as it is radiating away, it's cooling also. But even when it is hot, the corresponding uncertainty in the velocity, that due to heat, is small compared to the uncertainty principle. So uncertainty principle jiggling of speed is much larger than the thermodynamic jiggling of the speed. And this plays a greater role in giving the pressure. Why? What is pressure from the kinetic theory of gas? What is pressure? How is pressure related to jiggling motion? Pressure is 2/3 average kinetic energy. So therefore, if I know the, I can erase this thing because we can use that part of the blackboard to write down. So therefore, the pressure, the degenerate, so the quantum mechanical pressure coming out of uncertainty principle is what we call degenerate pressure. There is another way of deriving it through thermodynamic statistics, but I will not go. Yeah. Degenerate pressure of electron, I call it capital P. Small p was momentum. So capital P, I'll call it the pressure. So capital P will be roughly 2/3. This is the kinetic theory of gases tells me 2/3 the average kinetic energy. Now I'm talking about electron. And what is this jiggling velocity? Jiggling velocity is delta V. There is the uncertain velocity, so delta V square. That is the degenerate electron pressure. 2 gets cancelled, and I have the result that this is 1/3 ME and square. So it's what I'll call, by the way, this h by 2 pi is called h bar. So h bar, so I will use, so this is can be written as h bar by 2. Because h by 2 pi I call h bar. So therefore, I have h bar square, delta v square, h bar square divided by 4 r0 square and this.
Sir, I have a question.
Yes.
From where does the electron get the jiggling speed?
It's the uncertainty principle. Quantum mechanics tells you that if you try to, if the electron's position you know within an uncertainty delta x, then its velocity is uncertain. And how much is the uncertainty? Delta z. And because the electron density is so high, the electron's position you know within a radius r0. So r0 is the uncertainty in the position, and r0 is small. And because r0 is small, you know that you can locate the electron within accuracy of r0. Therefore, necessarily its momentum cannot be accurately known. So there is uncertainty momentum h by 4 pi.
So then So this jiggling speed is
No, it's an uncertainty. So let us be slightly more careful. Uncertainty meaning it can be anything. It can be minus delta p, it can be plus delta p, or any range within this. So it's random. And it is this random momentum leads to random velocity. So velocity can go from minus h bar by 2 r 0 m to plus h bar by 2. So it is random. And any random velocity will be having associated pressure. Because the pressure is average kind. Any random quantity will have an average thing, and that average thing turns out to be related to this delta V or delta V.
So I just want to clarify.
Yeah.
So this jiggling speed has nothing to do with temperature.
It has nothing to do with temperature. So even if you have a cold white dwarf, see, remember, what was the idea? Why was the white dwarf star was a mystery to astrophysicists? That now you have such a dense object, and the core of such a dense object is carbon, oxygen, nitrogen. And carbon, oxygen, unless the temperature is very high, they will not fuse. If they don't fuse, no more fusion reaction, then eventually this core will cool down. If it cools down, what stabilizes the star from gravitationally collapsing? And that is where Fowler was the astrophysicist who first recognized it is a quantum mechanical pressure, this pressure arising out of quantum mechanics, that will stabilize the star against it collapsing under its own weight. That is a remarkable achievement. So Eddington, if you go back to the history, Eddington was puzzled. As soon as white dwarf was discovered, Eddington didn't know how to explain. Eddington had already given the normal model of main sequence stars. So for Eddington, it was a big problem. And Fowler, he explained using this quantum mechanics. So it's interesting. History of science is very interesting. Every time a new theory works in one field, immediately clever people use it to explain a problem in another field. So Fowler, he had already, because these are what time scale we are talking about? 1926, 27. That is when quantum mechanics was born. And Fowler immediately applied it to white dwarf to explain white dwarf. And Chandrasekhar immediately used relativity and quantum mechanics to get this. That's what we are talking about.
So when I'm talking about the temperature, I'm talking about the kinetic energy over there.
Temperature is random bulk motion, the random motion of the atoms. Here, it is the randomness coming from quantum mechanics. It's not due to bulk velocity. It's a quantum mechanical uncertainty that is giving the randomness.
So, you just said that delta P can range from negative to positive values.
It's random, no? So random, like for example,
I want to say that what does the negative value of velocity signify?
velocity has a direction. So velocity can be in this direction, it can be in this direction. So supposing there is a random velocity, supposing I say that I don't know the uncertainty the uncertainty the velocity is between is 2 kilometers per second. What I mean is it can be minus 2 kilometers per second, it can be plus 2 kilometers per second. Velocity has a direction. Speed, if I call it speed, then it will be 0 to right. So therefore, our pressure, degenerate pressure of the electron, if the electrons are non-relativistic, then this results in the degenerate pressure is this. Now, R0 I know already, R0 square, so R0 is here, so therefore I can write everything in terms of the, so what all things can go? Yeah, this uncertainty principle I will not erase.